Last time, we evaluated the path through a multi-agent run instead of judging only its final answer. I'm Merdad, and today we're asking what that reliable path actually costs to operate. Every verifier, retry, and coordination step spends tokens, adds latency, and extends the execution path. Reliability is not free, but that doesn't make it wasteful. It means cost deserves the same deliberate engineering as accuracy and reliability. Every safeguard that makes an agent more dependable eventually appears on the bill. A verifier adds another model call, while a retry can repeat work the system already paid for. Parallel subagents each carry context, reason independently, and produce outputs that another component must combine. Those calls are often valuable because they catch errors and recover failed paths. The problem begins when we add reliability mechanisms without measuring the cost they create. A chat request usually exposes one model call, so its approximate cost is easy to predict. An agent request can fan out through planning, tools, verification, retries, and several cooperating agents before it finishes. The prompt may begin the run, but the harness decides how many calls follow and how long they continue. That makes cost a first-class system metric, alongside accuracy and latency. Track it on every run, bound it by design, and never wait for the monthly invoice to reveal the architecture. A multi-agent run often pays 4 connected bills. First, parallel subagents each receive their own context and generate their own tokens. Second, retries and replanning repeat parts of the trajectory whenever a step fails or produces weak evidence. Third, long context gets sent again across turns, so the system pays before useful work even begins. Fourth, verifier passes consume more calls to inspect, challenge, or repair the proposed result. A single agent already costs more than one chat, and coordination multiplies that difference. Notice the pattern. The largest cost drivers are also the mechanisms we use to improve reliability. Reliability and cost are not opposing goals. They are two measurements of the same design choice. Verifiers, reflection, retries, and redundant exploration can improve outcomes, while adding tokens, latency, and more opportunities for coordination failure. Treat that trade-off as a dial you set according to the task's value. Deep research may justify several independent paths and a strict verification pass. A routine lookup running millions of times may need one bounded path and an early stop. The framework should not choose that setting accidentally. Control starts by wrapping every model call with instrumentation that counts tokens, dollars, duration, and the step responsible. Attribute that spend to the user, feature, intent, and agent instead of recording one total after completion. Then compare similar requests through cost per intent, meaning the typical spend required for this kind of outcome. A slow increase across releases is silent degradation, even when success rates remain stable. The per-step cost from your observability layer reveals which planner, toolpath, or verifier introduced the change. Measurement tells you what happened, but a production harness also needs breaks that act before more money is spent. A post-hoc alert can explain yesterday's runaway loop, yet it cannot recover the calls that already happened. Instead, check the remaining budget before every model call and reject work that would cross the limit. Add hard turn caps, per-run token ceilings, and a circuit breaker for anomalous spend or recursive fan-out. The important behavior is automatic. The system stops itself. Many multi-agent examples leave these controls to the implementer, so the break belongs in your harness. After the breaks, 4 practical changes can reduce spend without removing useful reliability. Route extraction, classification, and summarization to cheaper models, reserving frontier models for steps that require difficult judgment. Cache-stable prefixes, such as system instructions and tool schemas, instead of processing the same tokens on every turn. End the loop when confidence is sufficient or another step is unlikely to change the decision. Finally, retrieve only the context each step needs and summarize history that no longer requires full detail. The cheapest token remains the one the harness never sends. Cost is a signal you design, not merely an invoice you receive. The harness decides how many calls a task requires, how much context each call carries, and when the loop stops. That makes unit economics a property of the harness, just like reliability. Once cost is measured, bounded, and attributed, it becomes feedback for improving the architecture instead of a surprise created by it. Carry 3 takeaways forward. First, reliability is bought through verifier calls, retries, parallel agents, and context, so set that dial deliberately. Second, instrument every call and track cost per intent. because rising spend can reveal degradation before outputs visibly fail. Third, break before you trim. Enforce pre-flight budgets and hard caps, then reduce unnecessary spend through routing, caching, early exits, and context hygiene. Budget the loop, and reliability becomes a choice you can measure instead of a bill that surprises you. This closes our production module on evaluation and cost. If this series is useful, subscribe to Multi-Agent Academy, and you can also connect with me on LinkedIn. Next is video 18, Code-Driven Harnesses, where deterministic code owns the control loop instead of always making the model the orchestrator. I'll see you there.